Folks, welcome to this amazing talk about that focus on modernization. And today, let's talk a little bit of a different topic because a lot of people talk about modernization, but how can you do it? How can you actually use something, a pattern, to help you to remodernize your apps, right? Because here's the thing: a lot of people say, "Oh, I need to port my application from so all the structure infrastructure to the cloud. How can I do it? How can I do it easily?" So that's how we bring the reliable web app. But it's not just that. We have a lot of points to touch about how can you do it very simply with Azure. So let me open up your comments tab if we need. And there we go. So who am I? I'm Pablo Lopez. I'm a guy. I like to joke. I'm just a guy. I'm just a little dude. I actually do a lot of things with technology. I just think so for some time now. And now I'm cloud advocate at Microsoft, but I work at startups. I worked at small companies. I was a contractor, so I did a lot of stuff. Before sysadmin, I actually did something with Proxmox. I don't know if some people here dealt with Proxmox before. It's really good. It's really exciting. PHP, but now I work at Microsoft in the .NET and AI part of it. So I'm a cloud advocate, which is basically I do talks, documentation, and talk with a lot of the product teams. And this is my LinkedIn. I always like to link my LinkedIn if people wants to connect. Let me know if you can, and it'll be a pleasure to me, to talk to you. I really like to talk with people in general. That's why I believe I got into DevRel. So that's how can you contact me. Okay, so what's our agenda today? Very simple. What is this? My question I should answer for you is very simple. How can I pick my application and modernize it? That's it. And because Microsoft has a very nice way you can do it, which we have like patterns of pattern. I'm gonna talk more about it, don't worry, that you can follow step by step with everything that we known for like this point decades on cloud experience and how can use that for your applications, and then everything works nicely. So let's go to understand what is RWA, which is the reliable web app. Then we need to why and how to apply this pattern. Then we're gonna have two parts of five. Two parts because this presentation is like 15 minutes, and I spent already 2 minutes just talking about myself. Can you see? So we're gonna need to talk a lot, and I need to show you some bibs and bobs of demos and how we implement inside of our demo because I have a big demo which I don't have it deployed, but you can see how we're gonna implement that inside of it, and you can learn more about everything I'm talking about. Okay, so before we go, let's understand this. What is RWA? I like to say that before that we have the cloud. I don't think I need to talk much more about why should I care about the cloud, because if you have doubts, I like to always clarify, right? So the cloud provides a lot of flexibility. If you have like a very monolith way that if you have an application, you need to worry. RWA deals with that as well. RWA is very accessible of monoliths as well. You can like port and it's done. Then you're gonna apply these patterns inside of your program. Then you're gonna iterate them. But we're gonna talk about this later. So if you want to understand how to use the cloud in general, you need to ask yourself, do I need scalability, flexibility, the cost, right? And Azure, because we have like those tons of programs, we have a tons of nice practices. So when people start to port a lot of those programs to the cloud, we have got a lot of doubts, a lot of questions, and to do that, they needed a framework, right? So for this, we have this. This is the Azure well-architected framework, which is very simple. It is our guide to how you plan your I'm talking the modernization, but I'm thinking like I was thinking of transportation for some reason. uh, so this is the way we do it. So it's key to understand how that works. And how that works then, this is our guideline. We have those pillars, which is classic, which is cost optimization, security, reliability, operation excellence, and performance efficiency. And those are together with the design patterns that we have. So workload design, references architecture, assessments, advisor recommendations, and service guides. So those are the 10 points that you need to worry about. 5 of those are pillars, 5 of those are design guidelines. Let's talk about the pillars first. Cost optimization. So when the first time a lot of people start to port things to the cloud, like imagine that, oh, I need to port, my monolith application for the restaurant, for example. I have a restaurant that, you know, that goes a lot of people, or sometimes go fewer people, right? Because it varies throughout the day. So what cost optimization does basically is that we can like scale and descale as we go, right? We can implement rules and how we do it. Don't need to like be, oh, let's put like this expensive machine because then you're gonna handle all the requests. You don't need that. You can actually do this automatically through. I think you folks know Bicep. If you don't know, Bicep is the way that we can automatically, I'll say automatically sometimes, that we can adjust a lot of configurations on your infrastructure. So you can go number of people. You can go to, for example, oh, I need a bigger machine. I need to scale horizontally, right? Okay, it's vertically in this case. Let's scale vertically in this case because I need more people. Now I have less, so it can go down. And basic concepts that you need to know, right? So scale vertically, horizontally, etc. So those are things you need to know. And security. There's a lot of people that just think that just porting to the cloud is just copying and pasting your application. But cloud has some concerns that you need to take care about. For example, you need to take about your APIs key much more carefully. You need to understand that cloud can have some parts that you need to take care on evasions. You need to take care about your for instance, your authentication part. So that's a lot of things you need to take care about. That is not usual to take care about when you have like your simple application running. So these are things you need to worry. Reliability. And you may ask, why should I worry about reliability? And I'm gonna give you a simple answer. You never know when you're gonna have a transient fault. It's very simple that you can have faults on your requests, and your system needs to be ready to handle both transient and non-transient faults. Which imagine that I send a request, it never arrives. What it does? Do I wait? Do I stop? What I do? What is the correct decision point there? So these are things you need to worry about, and then we need to care about the reliability of your operation in general. And talking about that, operational excellence. Basically, when you're talking about this operation excellence, we need to understand we could actually relate this as well with performance efficiency because operation excellence, it says in the name, right? It's an operational as intended. Did you design this properly with that in mind? And both performance and efficiency is it performant? You are actually choosing the right application because remember, Azure has like hundreds of tools. Basically, you can do whatever you want with Azure, but you need to understand this is the best tool for you. So those are the 5 pillars of the well architecture framework, and then we have the guidelines. Don't worry, I gonna not bother you with, but it's very important to understand that you need to understand your workload design. You need to have architecture that fits your product, your reference. You need to know your assessments. You can get like your advisor recommendations, and you can have your service guide. So those 5 there. There we go. This part is kind of big, but we need to take away from that. So now you know a little bit more about our well-architected framework. But why and how to apply this pattern, right? So let's be very simple. How can I begin my journey on replatforming all my apps into Azure? Then it comes this. This is the full name of RWA, which is Reliable Web App Pattern, right? They have the pattern in the end, but it's RWA pattern. This is a set of principles, basically. It teaches you the basics. So before you modernize your app into the cloud, you need to deploy it. So we are showing you how can you pick an app, basically, which is a monolith or somewhere, and then you're gonna do small changes here and there to put into the cloud. Then you're gonna modernize it where MWA. But first, you need to put it up. So that's how can you put it up, basically. So it shows you how to migrate to the cloud easily, safely, and to take care of small core updates that you can go for. So we have this example on GitHub, which is basically the reliable web app pattern for .NET, which shows you the reference implementation that we have. So this shows an example for Relic Cloud concerts. So let me get my, oh my God, my mouse and duplicate my tab because I have tons of tabs to show you today. And there you go. Let me go to home. This is our amazing web app pattern, guys. So you can see right here how it works. So we have everything here, and it shows our architecture. So this is a Relic Cloud concerts. There we go. And you can see right here everything that we need to have. So it shows primary, secondary. Oh, but I don't know how to do that. Don't worry. This is a sample app that you can learn step by step how you do it. You don't need to implement everything at once there. So basically, that's a thing you should take care of. But don't worry about it. This is like what your application should look at the end. You don't need to have this like looking this beautiful right now. You just need to take care of how can I go and towards this step. So we have that, and we have tons of workflows. It describes how it should work, how it's gonna run. So if you can see, I have VS Code here ready, but it's some time takes to deploy, right? So I not do a whole deployment, whole things today, but I'm gonna show snippets of code and a deploy app. I can do a small demo here because I already have that deploy, which is our Relic Cloud Lite, guys. But let's keep talking because if I go everywhere, I'm gonna go everywhere. I like to talk a lot, so let's focus here. You're gonna have here a container. So why dev containers? Simple. Gives you a standard base that you can develop from. That's it. Then you can easily deploy everything from Azure. There you go, and pretty nice. Let's go back to our slide. So we say it's a pattern, but it's more like a pattern of patterns, right? Because we have tons of things. I believe you saw that architecture. We have a lot of things that we implemented, right? Oh my God, it's so different from a monolith cloud. And how can I do it? So this is how you do it. When we go from your app, like your sample app, and then you go to your incredible application that you're going to deploy, you need to do three things. And each one takes a certain workload. I'm going to start first with the retry button. So you can see here in 1 and 2. There you go. Let me pick a laser. See, guys, now I'm using... Oh, no, I'm seeing on StreamYard. It goes with my mouse. Okay, so we have here 1. This one. So this is the retry button. So what it does, it handles failure. Those two do, like both 1 and 2. But this one is try again, basically. Just ask me that point again and see where it goes. The second one is circuit breaker. So imagine that you're getting anything from your app. You're getting nothing for your VNet. Nothing is going. What is going on? Give me something back. My application is asking my backend, and my backend is not providing it. Oh my God, what I do? Break a circuit. So you're gonna. It's a don't transient fault. Give up for now. It's give an error. Ask for the user to ask again. And then lastly, we have 3, which is we're gonna not cover today, which is cache aside. So cache aside, guys, basically it loads the pattern right here from the cache. So you can see here that we actually implement here a full cache and a database. This is other cloud services that you may need, but that's very important because remember, a lot of people can maybe are asking for that ticket again and again and again. Imagine that you are like, I don't know if I allowed to say brands on this on this on this conf, but I'm gonna say it. If not, I'm gonna receive a very strong word letter from my manager later. Imagine you're a ticket master, and then you have your Taylor Swift concerts. Oh my God, so many, right? So we need to take care. Of course, this will not handle that. I'm not saying that does, please, but imagine that you have that, and those are like basic things you need to implement, right? Imagine those are basic, both, but as I said, this is the first step of multiple steps. But now you know you need 3 before you go to the cloud. You need to have your retry, your circuit breaker, and your cache. Makes sense, right? before going to the cloud, you need to have this three very lined up, then you deploy. Pretty good. So let me take out my laser. There you go. It's my mouse again. And you may ask yourself, what is the objective of all of this, right? Because you have so many things that you can may try and do, right? And the objective of this are pieces. So when you're gonna migrate to the cloud, you have to have some objectives. So you need to have some low cost and high value wins. Imagine that you want to use a new AI service because everyone wants to do a new AI service. So if you want to do that, of course, you cannot run it locally. And of course, you have probably using an API. If you're already using an API, why not do all your ports there? No, all your ports going to the cloud. And then you're going to have like scalability and all the advantages that you are already using an API anyway for that. So that's a thing you can look towards. And follow the Azure well-architected framework with, if you forgot, I always like to go back because this image is very important. And you can use this, right? It's already there. You can use this very easily. Going back to my point. Make minimal changes to ensure security, reliability, and operation excellence. Sure. High availability with multi-region and cost-optimized environments for everyone. Okay, both true. Yeah, and true. I almost forgot seeing the slides. Both in production and development. You can have like a small, key for that. That's fine. And as I say, this is not the end. This is just the beginning because this is the roadmap that you can go with. So after you go to replatform, so you have your minimal code changes, you optimize for the cloud, and you have like your high value updates. Now you can go and refactor your application more deep. So you can go to the coupling architecture. You can target your modernization. What is targeted modernization is basically some parts of a program can be much more optimized to the cloud than you're writing them to the other parts. So you can actually target your modernization there, and you can have independent versioning and scaling for a lot of the small points of contact that you have on the cloud. So those are things that you need to worry about. So this is comprise a big guide, which is like enterprise-led patterns. So this is a patterns of patterns of patterns. So very big thing. And now you can go on premises, letting zone, replatform, and refactor. Okay, I'm talking too much, right? That's the thing. I need to show you how to start doing it, how those actually work. So let's go. Oh my God, I beat my microphone there. That's a problem if you're moving your hand too much. Need to optimize your cost of RWA. So how you do it? And I want you to think about this. It can scale very quickly. When I have cloud apps, those cloud apps can go ballooning fast on costs. And there are some ways you can do it to avoid that. How to auto scale? So you can use Bicep. If you already know about Bicep, I don't need to introduce you to Bicep. But if you don't, it's very good to know. So it's basically a Azure resource config, deployment config that allows you to write exactly how you want your resources to be deployed, which is pretty cool. And you can use that to have this scaled up and down as you want. And if it's requiring like X% of your CPU, for example, on your VM, you can actually go, okay, I want to scale vertically or horizontally for any request that I may have. And app services have already a very nice rule to do that. So you can actually write rules on your Bicep. So then your Bicep, boom, it goes up and down automatically without worrying. It's good because then it gives you three advantages. First, correct sizing. Correct sizing is good for basically cost optimization, but it has a good practice because then if you want to do horizontal and vertical, it gives you the right way that you can do both. So you don't like making like the biggest VM that you can. You don't need to do that if you can go horizontal. And you don't need like the smallest multiple VMs on horizontal as well. You can choose vertically as well. So you can actually do the correct sizing for every single VM that you need and how you scale. Scalable costs. So the costs here, remember what I said about that? Costs are different, and we know we need to always to optimize them. But how to scale them correctly is another question. And a lot of folks miss that point. So what you can do is that with this correct sizing, you can get very nice costs and you can understand how you do it. And because you're writing the rules, remember you're writing them, you can choose how you want them. And cost optimization, I didn't talk about that exactly what you're doing. And one thing we may add is that we need to take care about our SLA. SLA is our service level agreement, which pick the right Azure resources for those are very important because it's very key. Do you need like 99.99999%? A lot of people don't, right? So you can actually pick, depending on your SKU, you can pick correctly what you can pick. But usually, if you want redundancy, etc., those are things you need to worry about a little. But imagine that your application needs a very high number on the SLAs. So it really depends. I love reading comments because I go for 9 5s, right? Because it's 9 9 9 9. It's a very big SLA. So those are things you should worry about. But as I like to say, redundancy is key, but you need to understand if it fits your application. Because if I have my restaurant, imagine I have Pablo's Pizza restaurant. I don't think I need 9 5s. I don't think so. It would be funny though. Oh, my application is reliable every time. That would be hilarious. But those are things you should like take care on your whole app. Oh, 95 out of 5 available. Yeah. I misread that. I'm sorry. I mean, I want more that for my pizza restaurant. I probably want 90%, 99, 9.9. I don't know. Folks, comment. What is the correct SLA for a pizza restaurant? A pizzeria. Let me know. Yay! Now I'm gonna finally. I'm yapping for 20 minutes. Let's go to code. Whee! So I'll not deploy anything to Azure because I have two things to show you today. And it's a lot of resources, so I'm gonna compact this a little. So let me go here to first. Oh my god. Oh, I need to show one thing first. Yeah, I almost forgot. So our guide on RWA have this. This is our cost optimization part, and I'm gonna basically show the changes that I made from already deployed sample. So the sample is already deployed, and you can take a look and maybe scale. It would be so funny if they start scaling because so many people are taking a look on that. So there you go. So we have our sample. This is inside of Workshop. You can see here that we have our big sample, which is Rela Cloud Web. And we have our smaller sample inside of Workshop, which is Rela Cloud Lite. And let me show you what Rela Cloud Lite looks like. So this is basically a small app. There we go. Which you have tickets. So we have bands available, prices, everything that you may want from, your incredible application. Of course, you want a buy button here, but this is to be light. This is healthy. So there we go. Let's go back here. So what do we need to do? Imagine that I have so many, and I'm having so many people asking, "Oh, I want this new thing going." I have a big show which has like 10,000 people accessing my small website. Oh no, what I do there? So what you can do is very simple. You can go here and you can see inside of it we have like ACD sample or source, and you have our infrastructure. Inside of it, we have like bicep resources. There we go. Oh, I need you. Yeah, it's too small. No, this is too big now. Okay. Chat, does this look good? I don't know, chat. Maybe later, bicep. Maybe later. Uh, I got some comments on that by pizza. I gonna comment that later. So we have here our basic points on bicep that some people may recognize already: resource token, tags, web service name. But I want to show you folks that we have this. Ba-bam! Welcome to our app service plan. So what it does is that we have this thing here, which is our condition. So we have here a pivot point. So this is our SKU for this, and this is how it's being deployed. I need to explain how this is being deployed, then this doesn't make sense if I don't explain, right? So what is happening? So this is going to deploy as an app service, and then it goes to a VM there. There you go. And then it runs through a website, you know the deal. And I have here a small condition. Is it production? If is, congrats, we get like this beefy P1 V3 VM. If it's not, it's just a basic one. And then we get this. That's it. And not only that, we have here our auto scale bicep. And if you go here, you can see how it works. So you can see we have two things here, both for our service plan, which it goes and changes with its production, and or auto scale. And if you go to our auto scale, you can get the condition. And you can see we have some triggers here for doing that. So we have like here is our CPU percentage, our time window, and our statistic. So I need to explain what each one is doing, but very simply, this is basically if our CPU hits in time window of 10 minutes, the time grain here is 5 minutes on average. Like if on average of this time, it's bigger than this threshold. And many may ask, where is this threshold? It's right here. It's 85. If it goes up to 85, like 10 minutes, oh my God, it's getting so many people are getting to my pizzeria. You can get, then I gotta bump a machine. Which machine? Where it goes? Don't worry, I'm gonna show you how it bumps on Azure. So it is bumping every 10 minutes, but if it's less, it's like, it's less than 60%, I'm gonna go down one. So that's how it works. It goes up and then it goes down depending on the access that I have. So this is how the auto scale works. And if you want to know more, right, because you need to understand this language here. Let me open this to you. Let me get, I'm just a second, I need to, it's funny because I think, I probably opened every single documentation on Azure. Then I forgot about a documentation. I love that. The PT10 name documentation Azure. There you go. Thank you. Thank you, Bang. Love you. So, bye-bye. This is our auto scale settings. And if you take a small glance here, you can see how it does work. Then it describes what it does, blah, 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 but I want my profiles. Stamps and then, yeah, thank you. Flapping auto scale. Yeah, I gotta not find, I want to like the times that it does accept, but I'm not finding them quickly. We have predictive auto scale as well. You can do that, but it's another topic that we're gonna talk. Probably in another talk, not this one today. But now you know how simple it is. Oh, what I did? Yeah, thank God Control Z exists. So now we have this, and then what it's doing here is basically when I deployed, it goes, is it production? It is. On this case, it is. It goes to this machine. And then it will apply my auto scale depending on how many people are accessing it or the VM is getting too many hits. So that's it. Very simple, very nice. And I can do more complicated, absolutely. And I'm going to show you very soon how can we absolutely see more things related to it. But first, let's go to my app. So let me bring another tab. This is my Red Cloud web app. Hooray, congrats to Red Cloud. So, and here we have like our domain, which you probably saw, I showed you already, my website, my web service plan, and my SKU, which you can see, I already put it to production, so it's P1v3. And if I go to my plan, let me bring my another tab. You can see here, this is the auto scale setting. If you cannot find it, it's very simple. You can go to, see, it is our Apple Service Plan, settings, scale out, Then I have our scale out method because I'm scaling, you know, you can see completely vertically right here. So we can go and configure. And here you can see my conditions. Thank you very much. And you can see my rules. So here you go. As I said, bigger than 85, less than 60, and I have our assist limit. And you can do as well manual scales. But I don't think we need that because we're trying to automate as much as we can for that. So let me go this and put to the tab. And now you know. Let me see if I'm missing something. Oh, there you go. I almost missed something. I always miss something because, man, guys, there is so much to talk. So if you go right here, we have on the big Relics app this one. So we can see have a whole environment configuration map. And you can see how it works. So B1, B2, B3, B0, P1, P2, P3, S1, S1. So this is basically the name, the tier, the size, and the family. And you can always write rules for things like that. So it receives the properties here, go to the bicep, and we have here some zone redundancy. So remember that we have like two zones there. So you need to take note like how is the other skin is going, how it's doing that with the zones and everything, and then take care of it. And then it's explaining what I explained this earlier. And about SLAs. SLAs are very simple. This one, it's a classic, right? So you can composite SLA, just multiply. If you want to know for the single regions, you can do this. No, it's not that fancy, but it's important for you to know. Like, what is the R for the number of regions? And then you can get those. So, yeah. And then you have all the links for service agreements, etc. Yada, yada, yada. Okay, I want to know if we have like anything other than pizzas. I gonna read the pizzas comment, even though I still have the explanation for everything related to that. But I want to know the cost demo is done. I'm really happy with that. We are very on time. People are saying answer the call within 30 seconds, delivered in 30, 40 minutes. 60% of the time works every time. Okay, folks, sounds good. I love that you folks like joining on the pizzerias, the pizzas joke. I love that one. So now let's think about reliability, right? Because this is key on how we do everything. So what is a reliable web app, right? Because it's in the name. I cannot run from it. It's literally RWA. So there's a web app that is both resilient and available. What do those mean? Like what? Simple. Resiliency, self-heal, availability, operational. So a resilient app, it can self-heal, it can get out of trouble, etc. But available, it means it's operational. I can access, I can do things with it. So those are the simple definition of those, but those are very useful because I don't think we need to sell too much cheap on us, but those are very important to know. And why I'm saying this is because folks, cloud apps are not perfect. Even though people love to say they're perfect, they are not. Um, I want to know from comments if you have a comment that sometime a cloud app tried to give you a request and you never received, or you're sending a million times. Let us know. I love to have like those comments in chat. So because I like to make a fun experience for everyone. So please tell your better experiences with your cloud apps receiving calls. I love to read those. But as I say, you can have both faults and service operations. So what is things that didn't happen with you? Let's talk about the transient faults, right? Because we have like those two kinds of faults, and those are important to know. So transient ones are usually temporary loss of network, or you lost network, or your components are failing, or the timeouts occur and service are busy. But usually those are fine, right? Because those can self-correct. You can send them again and say, okay, it's fine. It happens. Send it again. Bah, let's send this again because we really need that thing again. So there you go. That's very sad. But the problem is on no transient because you're sending, but nothing happens. Why this is not receiving anything? This is already retrying multiple times, right? And it's not going. So those are usually permanent failures that persist over time. So those are two things, and you can see even on the signifier, right? Is a transient. Something is transient, that means just like for a small period, right? It's like it's doing something else. So that's very important. People are already commenting on those, and I love it. So I already gave you spoilers. What retry does, it's just try again. That's it, right? And how it tries is very important for you to know, because how can I easily implement a retry? So we have tons of ways of doing that. One of those is that we use poly. I need to check because sometimes we change libraries, and I don't know if the library changed. It's the last time that, so I need to take a look on that. But on the sample here, we are using poly, at least for now. And what it does basically is having like the data, the DB data book context. Here's a database, and they're gonna ask for something. Let's try 5 times and 3 seconds. Pa 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 pa. Okay. So simple and easy. The second breaker is as well kind of easy. It just stop trying. So we have here our HTTP policy extensions, and if we try those many times and 5 and then 30 seconds, yeah, just give up, give an error. Sorry, it's not accessible for you now. So yeah, those are very simple, but I need to explain you how they work. So let me go back. Oh, sorry, my cable is under my chair. The cable of my headphones. Just seconds, folks. Oh yeah, it doesn't want to quit. I'm stuck to the chair like this. Look, I love giving talks like that. And my laptop almost fell. That's great. Um, live demos. Okay, let's go. We are here. We are back to our reliable web app, and I'm gonna show you what we did here. So here I have reliability, and I just implemented Retry button, and I'm gonna show you how we implemented on Relay Cloud, like the big one, because we're showing just the small one, but I want to show you how we did like on the big one as well. So we can see right here that we need a setting. So I added a setting here, which is Retry Demo 2, and we changed some small bibs and bobs. So for example, we have here on our API that we change anything, but on our web, we can see that we just comment that. So I say, no, wait for our amazing new client here so it can actually change. And you can see that we already have a resilience get try policy. That sounds interesting. But you can see that we have another modifier there. And what is it? You can see that we added some extensions. So we have here our poly, wait and retry, and HTTP poly. Nice. And we have this new resilience. So this is our AI in sync policy, and we have everything related to that. So, you know, if it does delay, sure, give us a small delay here, 50 milliseconds, 500 milliseconds, and try 3 times. That's it. Then we're gonna add this to our program and say, okay, if get retry policy again. Just give that another shot. So what I would do is already written down, right? So it's 50 milliseconds, 3 times. Do it again. Pa, pa, pa. It fails, it should fail, and that's fine. Okay, so now you can see that how can handle those errors pretty easily. So this is and by the way, I noticed while reading my guideline again that we need to update because it's still with weather forecast, but it should be with Relay Cloud concerts. There you go. But here's the thing: this is a too small sample to talk about circuit breaker. We have that, we can implement that, but I'm gonna show you on Big Relay Cloud. So if we go here, this is our big app, like our big application. Load GitHub. Thank you. So we need to understand how it does work, right? So let's go to circuit breaker. So you can see here we have our startup.cs, which is inside of our API calls. And I want to see one thing. Let's search for, it's already there. Thank you. Love you. This is our service, add DB. But let me, yeah, notice it's too small for folks to sense. So this is that full structure. I believe you show you in the slide. Want to show you in which context it does. So it goes and try to get our services context right here, and it says, "Hey, give me that." Sure. There you go. And then if you need to add a concert, it goes and tries to connect and add to the scope. That's it. And you can see that it will repeat tons of times. So if I have another one as well relating to AI sync policy, which is for, I believe, for retry. I have one for retry as well here. So let's go there. It is here. Let me remember it's here. No, I don't think so. It's the other one. Oh, that is here. Okay. Sounds good. Let me remember. What is it? It probably is on retry or failure. There you go. And I want to see as well relating to. I want to show you something relating to. I know I have one on retry on the app configuration SDK, but I need to take a look. But yeah, these ones are the things that we have everything configured. Let me control minus a bit here. And I have here some classics. You have singletons, we have just use one, because if not, gives an exception, but I'm trying to find one that's specific. I don't know, remember, it's here, is it? Okay, I'm gonna try to find it later. So now if our demo done, I want to show you a small thing here. Where is it? It's on, resource visualizer. Yeah, I almost forgot about that. Whee! So I think the folks know about resource visualizer. I not need to talk to you anything, but I think the folks may remember is that it can help you as well to understand how. I need to look at the camera, Pablo. You need to understand how it connects with everything. So this is a small example, so it doesn't show. But if you go to the big Relay Cloud, it actually shows like a lot of the timers. And then you can see if it's actually needed to go to retry, it's going to circuit breaker, or if it needs to go to cache aside. So those things are really important for you to know, is that you can use a lot of the resource visualizer to see if it's going well, and you can use the activity log. I'm saying this because some people don't know, but you can actually take a look a lot on both this and others to understand how it's performing. They have load testing as well, but that's another time that you need to understand. Do I have something else? I think only showing the GitHub repo, and that's it. Let me show the GitHub repo then. Boom. Let me control minus here. And show we have here tons of instructions, especially on the circuit break button right here. And you can do the same thing here. So you can actually add our policy, and then you can just add into the service fee. So I have here on the async policy, and then you go to, let's go there. I don't think it's running, but let's go there. Let me tab because it's horrible. The handle transient error goes to a status not found and goes to this time span of 30 seconds. Then we're gonna need to tell this on our thing. So let's go to the ticket service and say, hey, if everything bad occur, Let us know. Let me format this because this is so much stuff. And this is not working. Those two. And bye-bye. It's done. Now you have both your circuit breaker from resilience, and then it will handle your errors as we go. Okay, I heard that I have to give some time for Q&A. So I start to open any questions that you folks may have, folks. And I'm gonna read some funny comments. Seeing if we have.
So,
Mm.
Pablo, there were some folks talking about downtime. Gosh, I don't have any downtime with my application. Downtime is something that is a factor of not having enough resiliency, not having enough, to your point, replicas and having circuit breakers and retry capabilities so that you can handle pressure, right?
Yeah, so folks, one thing about resiliency that you need to take care of is that I always like to say, are you investigating your application, how it's behaving? Because I don't even try to say, oh, it's not. It's because we have so many things. Because here's the thing, Jeff, we have to understand when people start talking about this, is that we have to understand that people are pouring to the cloud. A lot of people don't have
Yeah.
experience of that.
Yeah.
So people need to understand how is your application failing, right? You're having too many accesses. Are you scaling correctly? Are you having correct connections? I read a lot of DNS, and it's
Yes.
true. It is
It is.
absolutely true. Don't worry, folks. I
Yeah.
absolutely get
It is.
DNS blowing on your face. So yeah, so those are things that we need to worry about as we go. But the tip I always give to people is your application scaling? Are you checking the rules?
Yeah.
People sometimes
Yeah.
code put on bicep and then they just forget to check. Is it scaling? If it is scaling, how it is scaling? Are you going horizontally, vertically, and how you're doing that? Are you distributing? Is the applet distributing that correctly? You need to check that. And I'm gonna go back. Sorry, because I remembered
Please.
one more thing, which is relating to this. So we have here, and we have scale up.
Yeah. Yeah.
And you can see right here how it works. So I forgot to show this, the cost per hour. I need to show the cost per hour.
Yeah, it's
And
kind of
you can,
important for folks who are running app service to be able to see different size instances have different cost.
yep. So if you don't need anything big, I was like to say go F1, B1. You don't
Yeah.
need too much, but you can see that sometimes it jumps double, right? And you can try to handle multiple things with a machine, but imagine that you're doing like AI inference, right? Yeah, first I know it's not recommended, but some people do. You know that people do.
Yeah. They try
And
to. Yeah.
they try. And a machine will be busy. That machine will be busy. It will not accept any other request. You're gonna need to scale horizontally. If it not, it will not do anything else. So
Yep.
take
Yep.
care of how you're scaling and how you optimize your costs. That's very important.
On YouTube chat, there's a comment about, hey, let's move to the cloud to make our app more reliable. Well, you can make your app more reliable because you have scale, you have multiple machines. To what you've shown us here, Pablo, we can set up those rules to grow and reduce size of our application to handle the workflow that's coming in. That's the amazing part here, right? We no longer have to wait for new machines to be shipped and have to get them racked in the data center on the weekend, which leads to an excellent point that you made earlier. Your pizza shop, you don't need 5 nines all day, but I think the unspoken part that you point that you made there, you need 5 nines while the pizza shop's open. So we don't
That's
need
absolutely true.
we don't need the pizza shop website running at 9 in the morning because we don't sell breakfast pizza. There's a
No,
good time to rack that new server.
you're making the case, Jeff, for people now doing pizza shop with like local.
I used to I share this story every now and again. I used to work for a company that made education software for
Mhm.
schools to use. Well, in the States, in North America, in the summer months, June, July, August, the schools are closed. That's when we did our upgrades to the applications. That's when we upgraded hardware because nobody was using the application. September
Mhm.
at the beginning of the school year comes around, we got to be up and running. So having rules like you're showing, you've upgraded your applications, you're going to push them to the cloud, you're going to take
Mhm.
advantage of Azure scale. Those rules are so important.
Absolutely. I'm gonna show two QR codes right here for you because I know you're
Please.
gonna show more things on. I love .NET Copilot. I know we have very amazing things, but if you want to know more about this, scan this QR code to go to Reliable Web App. If not, let me paste the link as well, right? Because me just talking is not correct. I need to paste the link as well. So, folks, if you want to know more about reliable web app, be my guest. I love this project. And if folks saw, I ended like 5 minutes remaining. If I deployed any demo here, I would need an hour and a half. Because those take some time to show it deploy. So if you want to learn more about reliable web app, let me know. There you go. And generative AI for beginners. I know a lot of people say, really? Even here? No, seriously, this is not a bad thing. I wrote this doc as well, and that's something I love. So if you have any questions to know about Gen AI for beginners net, let me. And it's funny because when I need a link, I cannot write them correctly.
Yeah,
I mean, I had to do the jokes. There we
sure.
go.
Oh my gosh,
I
right? We got
I
to be a little bit interesting here as we're chatting and teaching. And
yeah,
it, I really think that this is an important lesson for folks to see and be aware of these architecture concepts as you grow your application beyond just running in your local data center, running with an old version of .NET, taking advantage of containers and scalability and replicating applications using circuit breakers and the various scale options. Those architecture concepts are really important once you start to grow into the cloud and upgrade, modernize, and take advantage of all those great facilities available.
absolutely. And I always like to say, we talk with the people that work on this project internally, and this is just a step to go to MWA, which is the modernization part. And then you're
Yes.
gonna learn about security. You're gonna learn how to rewrite a bunch of your code to be more cloud compliant, and understand how can you do it safely. And remember, what I showed you was 2 of 5. So we have like this workshop takes if you do the whole workshop, it takes like 3 hours. And
Okay.
I really
Okay.
recommend if you want to port something, learn from this workshop and let us know what you think. We love to have some feedback, me and the team from RWA as well.
I shared the
And
links in chat so folks can click through and bookmark and follow up on their own time, take time and go through it. Th- There's a lot of great points there that are going to help you grow your applications.
exactly.